So in this video, I'm going to talk about some different operations that we can apply to sets, and then how Venn diagrams can help us answer those questions. To do this, we're going to start with a handful of terms that we haven't covered yet. So the first one is the intersection of two sets. And if we have two sets that have common elements, then all of the elements that are common to both of them are called the intersection. The symbol for an intersection is this upside down horseshoe shape. Okay, that means an intersection. And if we're thinking about, let me sketch a quick Venn diagram here. If we're thinking about a visual representation of this, then if the two bubbles are A and B, the intersection of A and B is everything inside that overlap. Okay, so that's the intersection is what's common to both. And then if two sets do not have any similar or any shared elements, then we call those disjoint. For example, in the sets of numbers and subsets of numbers, we have rational numbers and we have irrational numbers, but there are no numbers that are both rational and irrational. So those two sets, rational and irrational, are disjoint. Okay? And symbolically, we write that the intersection of those is equal to the empty set. Okay? And then the union of two sets is all of the elements that are in either A or B and possibly both. Okay? The symbol for the union is a horseshoe shape, kind of like a U, but it doesn't have a tail. And if we're looking at a Venn diagram, then the visual representation here is everything that is in A and, I should say, or B. Okay, so it's everything in A, everything in B, everything in the overlap. Okay, and then the difference of two sets, if we are subtracting sets, and here the order does make a difference, okay, it needs to be A minus B, then we get all of the elements that are in set A but not in set B. That doesn't mean we can't do B minus A, that just means we're indicating a different region, okay? Visually, if we have a Venn diagram, another quick sketch here, if the left is A and the right is B, then A minus B is everything that is inside this bubble but not in B, so it would be this region right here. Okay? All right, so what we're going to do now is look at a large example. We've got a pretty big Venn diagram here, and our universal set is all of the counting numbers under 20, so 1 through 19 because we don't include 20. And we have three subsets, P, Q, and R, which are multiples of 2, 3, and 4. And I'm going to label my box as U, and then P, Q, and R will be my subset bubbles. Okay? What we want to do first to answer the questions below is we want to create a Venn diagram, meaning we need to place all of the values from 1 to 19 into their appropriate spaces. And we can't have a number that's in more than one, we can't write a number more than once, so we need to figure out, does it go in an overlap? Is it just in P? Is it just in R? That sort of thing. To do this, and this is not necessary, but for our purposes, I'm going to write out all of the elements that are in the universal set, okay? Because then I can kind of cross them off as I go, as I put them into the Venn diagram, just to make sure that I've used all of them. So I'm going to start with that. And I certainly wouldn't want to do this if I were looking at a set of like the numbers under 100 or something, but 19's not too bad, and it'll help us talk through it. Okay, 15, 16, 17, 18, 19. Okay, so here's my universal set, all the numbers from 1 through 19, all the counting numbers. And to fill out the Venn diagram, I want to start with intersections, okay? I want to know which elements are common to more than one subset. And actually, I'm going to start with all three subsets. So my first question to myself is, what is an element of P, Q, and R? In other words, what is a multiple of both 2 and 3 and 4? Okay? And in this case, I'm scanning through all the numbers. The only one that I find that satisfies that is the 12. So I'm putting a 12 in this intersection space between all three of the bubbles. That 12 is inside all three of them. Okay? Now I'm going to step over to just doing 2 intersections at a time, or 2 subsets, excuse me. So I'm looking at P and Q. P is multiples of 2, Q is multiples of 3, so I'm looking for multiples of 6, which are going to be 6, and then 12 we already have, and 18, okay? So 6 and 18 are the 2 numbers that are elements of P and Q, so that's the intersection, P and Q, but not R, okay? And we already have 12 in there. Like I said, we're not going to write that twice. Next, I'm looking at P and R, which is multiples of 2 and multiples of R. Multiples of 4. And here, we notice that since R is multiples of 4, and all of the values that are multiples of 4 are also even numbers, so they're also multiples of 2, we actually have that R is a subset of P. Okay? And what this tells us then is that there aren't going to be any values or elements of R that are not in the intersection with P. Okay? So really, if I just look at all of the elements of R that I haven't already named, they're going to show up in the intersection between P and R. So that's going to be multiples of 4. So 4, 8, we already have 12, and then 16. So 4, 8, and 16 go in this overlap section between P and R. Okay? Looking at Q and R, I'm looking for multiples of 3 and 4. To be a multiple of 3 and 4, it has to be a multiple of 12. 12 is the only one. So really, there are no values that go in this little area here. Now, I'm putting a little X in there just to remind myself when I look back at it. Yes, I've already checked to see if there's something that goes in that space. You don't have to put an X. You can just leave it blank. It's going to look blank if you're looking at the textbook or the online examples. But that will help me just keep track of which regions I've already considered. Okay, now I'm going to do the sections that are just, so like the part of the P bubble that is only P and not overlapping with either of the others. So now I'm looking for any multiples of 2 that are not already in consideration somewhere. And that's going to be 2 and 10 and 14, and that's it. So 2, 10, and 14 get added out here. So we now have all of the multiples of 2 inside the P bubble somewhere. And then for Q, I'm looking at multiples of 3 not already named, and that's going to be 3, 9, and 15. So 3, 9, and 15. And multiples of R that are not already named. Okay, well remember we said R is a subset of P, so there are no elements unique to R. Okay, so I'm going to put a little X there just to keep track as well. Okay, I do still need to consider the rest of the unused entries. Those are going to go inside the box, but I'm going to put them outside the bubble. So that's going to be 1, 5, 7, 11, 13, 17, and 19. These are still part of our universal set, but not part of either any of the 3 subsets. So those get left off. And I'm actually going to pause here and do this video in 2 parts.